Hello, everyone. Can you hear me good? Hi. What if I told you that a single container running inside your cloud environment can use an internal AWS protocol and hijack the credentials of another more powerful container on the same machine? In some cases, that's all it takes to take over your entire cloud environment. In today's talk, I'm going to show you exactly how that's possible using a vulnerability that I found called ECS-cape. A wordplay between ECS and escape, because it sets an ECS task, escape its assigned boundaries. Now, before we begin, let me introduce myself. So my name is Naor Haziz. I'm a software developer and security researcher at Sweet Security. And in my free time, I also like to go snowboard and go to music festivals. I'm also a part-time DJ and a huge fan of Rust programming language. After this talk, I'm going to hit the clubs in Vegas, so you're more than welcome to join me. So, here's what we are going to cover today. First, we're going to have a technical deep dive about the vulnerability, technical background, about some key concepts that you should know for this talk. Then, I'm going to share with you my personal story of how I encountered this vulnerability. Afterwards, we'll have a technical deep dive into the vulnerability itself, some impact and mitigation techniques, demo, and key takeaways. Now, before we deep dive into tech, let me give you a reason to stick with me. According to a survey, a third of the developers using orchestration technologies rely on Amazon ECS. That makes it one of the most widely adopted orchestrators, and this means that this talk is directly relevant to a huge portion of real-world production workloads. So, let's begin. First, I know some of you are familiar with this concept, so I'm going to talk about it, and we'll see how it goes. First, I want to talk with you about what is IAM. IAM stands for Identity and Access Management. It's the system in AWS that defines who can access what and what can they do. It has two main building blocks, policy and a role. A policy is a JSON document that lists allowed and denied actions. For example, this policy grants an access to S3 bucket, and that one grants access to launch an EC2 instance. A role is an identity with one or more policies attached to it. Roles are assumable, meaning you can receive temporary credentials tied to the role permissions and act as that role. Next, what is Amazon ECS? Amazon ECS is a native orchestration service. It's essentially a simpler managed alternative to Kubernetes. It runs Docker containers in your cloud environment, and it's deeply integrated with AWS core features like IAM, logging, and networking. There are three core concepts that are referred to throughout this talk: cluster, service, and task. In simple terms, ECS cluster is just a group of EC2s managed by Amazon ECS. These instances are where your containers are going to run. Each instance is assigned with a role called instance role. In order to ECS to function, this instance role must have a specific policy called Amazon EC2 Container Service for EC2 role, the longest name ever, and it contains basic permission for ECS to function, like communicate with ECS, access to pull container images from ECR. Inside that EC2, you'll find service and tasks. In simple terms, service is its ECS way of saying, keep this task running for me. It handles things like restart, scaling, and deployment. A task is a single running unit defined by a task definition. These are where your containers are going to run. It contains one or more containers, which are the actual processes doing your work, like your app, sidecar, or logger. In ECS, each task is assigned with its own IAM role, referred to as task role, and another special role called task execution role. The task execution role is intended to use for ECS, and it's not accessible to the task itself. It grants ECS permission to pull container images and fetch secrets for the task itself. For example, let's say that we have a task that needed access key to a MongoDB. ECS itself will fetch the credentials for that MongoDB for the task, using the task execution role, and then inject it to the task as environment variable. And therefore, it will be able to access the MongoDB without ever accessing the task execution role. Next, what is the task role? The task role defines which action the containers inside the task can do in your cloud environment. Even though tasks might run on the same EC2 instance, each one gets its own isolated permission. As you can see, each task has its own role assigned to it. ECS has two launch modes, Fargate and EC2. Fargate is completely serverless. Just define your task and let AWS handle the rest. ECS means that you manage the infrastructure yourself. The EC2 instances runs in your cloud environment, and everything runs in your cloud environment. Today's talk will focus on EC2 launch type, because this is where the vulnerability actually works. So let's zoom in on how ECS works on EC2 launch type. As I mentioned before, each instance is assigned with a unique role, the instance role, that has a specific ECS permission. On that instance, you'll find the Docker daemon, which actually runs your containers, and a component called the ECS agent. The ECS agent acts as a bridge between AWS control plane and the instance itself. The ECS agent uses the instance role to authenticate to AWS control plane and receive instruction from it like, start this task, stop that one. This whole unit, EC2 plus ECS agent, is what AWS refers to as container instance. It has a unique ARN, and you can find it in your AWS console. That's it for the technical background. Let's move on to the discovery story. So, here's how it's all started. As you know, I work at Switzer Security, and I was working on a main detection and response component, the EC2 sensor. One day, my manager, Ron, came to me and asked me, can you monitor ECS tasks? My initial response was, yeah, sure, let's try. Why not? As I mentioned earlier, we know that the ECS agent communicates with Docker daemon to span the containers of the tasks. So I figured I could do the same and get data about the task running on the instance. Inspecting running containers, I noticed that they have these labels containing almost all of the information that I needed, like the cluster and task ARN, task definition family. But one thing was missing, the service name. I really wanted to know in which service the tasks are running, and this information is nowhere to be found, and it made me really, really sad. So I started digging online, and I found this endpoint called Task Metadata Endpoint version 4. It's a unique endpoint that the ECS agent exposes to each task running on the instance. It returns tons of useful information about the task itself, like ARN, revision, CPU, and memory limitation. But most importantly, it returned the service name, which I really wanted. Here's where things got interesting. I wanted to get the service name myself, so I assumed I could do the same as the ECS agent. I assumed that the instance role would have permission to list the running services. But when I went to AWS console, I looked at the instance role permission, and these permissions are nowhere to be found. So how was the agent getting that info? The first thing I did was to set up a proxy server and inspect the ECS agent communication. That's when I noticed something really interesting. It was connecting to ECS service using a WebSocket, and it was passing a specific query parameter called send credentials equals true. That immediately made me suspicious. Here's a real message that I captured, showing real task credentials over that WebSocket. So I had a thought. Can I impersonate with the ECS agent? If I'll be able to trick AWS control plane into thinking that I am the agent, can I get those credentials too? I went to my manager, Ron, again, and showed him what I found, and I told him, Ron, look, this is really interesting. I really want to research it. And Ron, being Ron, nodded and told me, you have 3 days. And I took it. And that's where the hunt began. Now we'll deep dive into the vulnerability itself. First, I wanted to point out that the ECS agent is completely open source. It was really helpful for me in my research. I encourage you to go on GitHub and search it. And if you have any interesting questions or findings, feel free to reach out. I would love to hear from you. So let's look at the instance role. As mentioned earlier, it has this specific policy, and it has specific ECS permissions that play a crucial role in how ECS functions, as you'll see why shortly. So keep them in mind. The register container instance, discover poll endpoint, and poll permission are crucial to ECS. So the first thing that the ECS agent does is to register itself as a new container instance in the AWS control plane. It's doing it by using the register container instance permission that I mentioned earlier and calling an API that called, surprisingly, register container instance. When this stage is done, the ECS agent receives back the newly registered container instance ARN, and it's now available in AWS console. I went online and searched about this API, and I saw this note from AWS documentation stating that the action is only used by the Amazon ECS agent and not for use outside of the agent, which of course only made me more interested. Then the ECS agent is using the discover poll endpoint permission and call API called discover poll API, discover poll endpoint. This API returns back a specific URL we'll refer to as poll endpoint URL. Here's an example of a typical poll endpoint URL and how it might look like, though it may vary depending on the region and the availability zone. I searched online for this API as well, and I found the same note stating that it should not be used outside of the agent, which of course only made me more interested. So later, when the ECS agent received the poll endpoint URL, it takes it and builds a WebSocket request with it, using a bunch of identifiers as query parameters, and of course, the send credentials equals true parameter we saw earlier. Then, when everything is set up, the ECS agent attempts to connect to AWS control plane and to the newly created WebSocket. At this point, AWS control plane only validates one thing. Does the ECS agent has the ECS poll permission? Luckily, the instance role have this permission, and the connection is now authenticated. Once the connection is open, the control plane starts sending the credentials for both task and task execution role over that WebSocket. What is going on over that WebSocket? This WebSocket is communicating using a protocol called ACS, which stands for Agent Communication Service. It's an internal AWS protocol, which is meant for communication from the ECS agent to AWS control plane itself. It's non-documented, but we know it carries messages like task metadata. This is where the service name that I've been searching for been. Agent-level directives, like configuration updates, and most importantly, the IAM credentials for both task and task execution role of all of the tasks running on the same instance. So let's summarize the ECS agent flow and see how it works. The first thing it does is to register itself as a container instance using the register container instance API. Then it calls the discover poll endpoint and gets back the poll endpoint URL. Afterwards, using a bunch of identifiers as query parameters, it constructs the WebSocket request of the ACS protocol, and later it authenticates to AWS control plane and receives the task and task execution role of all of the tasks running on the same instance. So here's the real question. Can a task impersonate to the ECS agent? Let's find out. The first thing we need is to get the poll endpoint URL. But the problem, we don't have the discover poll endpoint permission. Here, you can see that the poll endpoint URL follows a predictable structure. It contains the region and the availability zone, which is the numbers going from 1 to 9. So that means that it's possible to brute force it. We can attempt to connect to the brute force poll endpoint URL, but then we will encounter in a new problem. We don't have the poll permissions. This is where I had an idea to use something called IMDS. IMDS stands for Instance Metadata Service. It's a special HTTP endpoint available in each EC2 instance, and it returns metadata about the instance itself, like region, instance ID, and private IP address. One of the main features of IMDS is to return the credentials of the instance role of the EC2 machine itself. In ECS, IMDS is enabled by default and accessible to each task running on the instance, meaning that using IMDS, each task running can get the credentials of the instance role, the same one used by the ECS agent. So now that we know that we have the same credentials used as the ECS agent, We can use the discover poll endpoint permission and call the discover poll endpoint API just like the real agent. Then we'll receive back the poll endpoint URL. Now, we need to take the poll endpoint URL and construct a valid ACS WebSocket request with it. The problem, we are missing the identifiers that needed to construct it. Most of the identifiers I was able to get using IMDS and task endpoint metadata version 4, but again, one thing was missing. The container instance ARN, which again made me really, really sad. So I went back to the instance role, hoping it would have permission to list the container instances. But no luck there. It was missing the list container instances permission. Then I tried something else. I thought I could try and register myself as new container instance. Although it worked, it had a couple of downsides. First, I'm now running in a different container instance, which means that in AWS perspective, I'm not running on the same instance. And second of all, AWS will start sending me instruction to execute task, which I don't have the permission to execute because I can't talk with a Docker daemon. And therefore, I'll break ECS, which I didn't wanted. Later, I tried and digging around about the ECS agent code, and I found that it was writing the container instance ARN into a bold DB over the host file system. In ECS, there's a feature to create volume and mount point. So I thought I could mount the host root file system to the running task, and then I'll be able to access the bold DB and get the container instance ARN. Again, it worked, but it had really big downside. This relies on specific configuration that mount the host root file system to the task, which is not that common in real-world scenario. This is where I got lucky. I found out that the ECS agent exposes another API called Container Retrospection API. This is a unique endpoint that the ECS agent exposes to each task running on the instance, and it returns the cluster, the container instance ARN, and even the agent version and hash, all of the information that I needed to fully impersonate to the ECS agent. With everything in place, I can now craft a valid ACS WebSocket request using all of the identifiers that I need, that I got using the introspection API, IMDS, and task metadata endpoint version 4. So now, by using the instance role, we can authenticate to AWS control plane and receive back the ECS poll permissions. And therefore, the connection is authenticated. At this point, AWS control plane will start sending me credentials of both all of the tasks running on the same instance and task executions of all of the tasks running, thinking it communicates with the real ECS agent. What I get back are not some roles ARN or something like that. I get already assumed credentials by AWS on my behalf. Why is that good? Two reasons. One, I don't need to call assume role. And two, if I look at CloudTree logs, you can see that the user agent and the identity that assumes the role are the ECS itself. So it's selfie. I get the raw plain text credentials. So to summarize the ECS-cape flow, the first thing we do is to use IMDS and get the instance credentials. Then we call the discover poll endpoint and receive back the poll endpoint URL. Afterwards, using IMDS, task endpoint metadata version 4, and the container introspection API, we can craft a valid ACS WebSocket request, connect to AWS, and receive the credentials for all of the tasks running on the same instance. I showed it to my manager Ron again, and he responded with a great success. What AWS documentation have to say about it? So here's from AWS website saying that a container never has access to credentials that are intended for another container that belongs to another task. That's the promise of task roles: isolation, security, separation. But as you can see, using this technique, a task can actually reach beyond that boundary. Here's another documentation from AWS about the task execution role. They are saying these permissions aren't accessible by the containers in the task. According to the documentation, the task execution is only available for ECS itself. But as you saw, again, using that technique, a task can actually reach beyond that boundary. So what is the impact of this vulnerability? First, let's look at a typical ECS setup on EC2. Here we have two tasks running on the same instance, one with lower privilege and another one with higher privilege. Now, this is common in ECS, different IAM roles, same EC2 instance. Now let's say that the lower privilege container gets compromised by an attacker. With ECS-cape, the attacker can now pivot laterally across the instance, meaning it can hijack the credentials of the higher privilege role without ever compromising the higher privilege task. Then it can use these credentials to access resources that were out of reach for the lowest privilege task, like S3 bucket. Here's an example about a task execution role. For example, let's say that we have a task that needs, again, credentials to access a MongoDB. ECS itself will use the task execution role to communicate with AWS Secret Manager and pass it to the task as environment variable, and therefore it will be able to access that MongoDB. But when ECS-cape is in play, the story changes. The exploit allows to hijack the credentials of the task execution role meant for ECS themselves, and then we can use it to communicate with AWS Secret Manager and fetch the credentials to the MongoDB ourselves. Again, we get the credentials that was never meant for our task and was for another task running on the same instance. In this case, these credentials was meant only for ECS agent itself and not for any task running on the instance. Okay, now I'll give you an example about multi-tenancy. This is a common setup. Here we have two tenants running on the same EC2 instance in the same ECS cluster. Each tenant has its own tasks, its own databases, and its own secrets. Access control relies on IAM and task separation, assuming the tasks are securely separated. But ECS-cape lets an attacker from tenant 1 to hijack the credentials of a task that meant for tenant 2. And therefore, they mean they can access data and services they should never see. This is tenant escape, and it's dangerous because teams may often think that IAM roles and task separation are enough. The impact goes beyond just credentials. It also exposes metadata about the other task running and the instance itself, because we are implementing an internal AWS protocol which reveals a lot of data about the cluster itself, which was out of reach before this vulnerability. So let's summarize the impact. First, cross-task IAM role hijacking. From one compromised task, we can reach the credentials of all of the other tasks running on the same instance. Second, abuse of task execution role. We can use the ECS-cape to hijack the credentials meant for the ECS itself and not for other tasks running on the instance. And then we can access secrets or private repository that were out of reach. Third, access to ECS internals. By implementing ECS, we were able to get data that were out of reach before. And lastly, there's no misconfiguration needed. IMDS is enabled by default in each ECS setup, and the instance role is configured with these permissions, so there's no misconfiguration needed. This comes with a default ECS setup. I prepared a demo for you guys to see the ECS-cape in action. So I created a cluster, which I called ECS-cape, and it has 3 tasks running on it: ECS-cape task, S3 control task, and database task. Let's look at the ECS task definition. It has task role called ECS-cape role, and it has no task execution role. The task role has the permission deny wildcard, meaning it has no permission to access anything in your cloud environment. Now let's look at the S3 control task. It has task role called S3 control role and no task execution role. As you can see, it has the policy Amazon S3 full access, meaning it can do anything it wants with S3 buckets. And I created an S3 bucket called Black Las Vegas 2025. Now let's see the vulnerability in action. This is video from AWS console, and we have also a shell attached to the ECS-cape task. Okay. So you see the Black Las Vegas 2025 S3 bucket. This is the shell from the ECS-cape task. And as you can see, using Amazon command line, it replies with access denied to the action of trying and deleting that bucket, because we don't have this permission. But now we'll use the ECS-cape command line, and you'll see it logs the hijacked credentials of all of the task and task execution running on the same instance, and it logs that the S3 bucket is now deleted successfully. As you'll see now, we'll go back to AWS console and refresh the page of the S3 bucket, and you'll see that this S3 bucket is now deleted. We didn't have the permission to do that before, but now, using ECS-cape, we have. Now, I created another thing called the DB secret. This is a secret in AWS Secret Manager. And let's look at the database task. The database task has no task role, and there's task execution role called secret execution role. This is an example about task execution role hijacking. As you can see, in the task definition, I define the DB secret, which points to the newly created one, and I have the permission to read that secret from AWS Secret Manager. Now, as we'll see in the video again, we have the DB secret in AWS console, and now we'll go to the shell on ECS-cape. Using Amazon command line, we'll see that if we'll try to read that secret, we'll receive access denied, because we didn't have these permissions. But again, when ECS-cape is in place, the things changes. It will log all of the credentials of all of the tasks running on the same instance, and it will log also the plain text value of that newly created secret, as you'll see shortly. Super secret password. It was out of reach before, but now we can access it. So, after giving this talk and showing it on my blog, a lot of people ask me about CloudTrail logs. So, here's the interesting thing about it. You can see the call to discover poll endpoint, but it's logged as it comes from a legitimate instance ID and the instance role itself. This is the exact same call that the real ECS agent do. So during normal operation, from AWS perspective, it looks like normal operation. There's no anomaly here. Here's another interesting thing. If we'll go to CloudTrail logs and try to monitor about the S3 deletion, you'll see that it's logged that this action came from the legitimate S3 control task and not from the ECS-cape task. There's no mention of the attacker container, no sign of the hijack. And again, for the task execution role, we'll see the same thing. It will be logged as it comes from the database task itself. There's no sign of the attacker or the container, just assume role and session time to the real task. The command line project that I showed you called ECS-cape is open source, and it's available on GitHub. I encourage you to go and search it, contribute, or talk with me about it. I would like to hear from you. And it's written in Rust, well, because I love Rust. Sorry, guys. What about the mitigations? Let's talk some mitigations. OK, the first thing you should do is to disable IMDS access to the task running on the instance. If you disable IMDS access to the task running on the instance, they won't be able to get the instance role, and therefore won't have the poll and discover poll endpoint permission, and won't be able to impersonate to the ECS agent. Keep in mind to never disable IMDS on the instance level, because the ECS agent relies on it, and if you'll disable it, it will break ECS. This is from AWS documentation. This is how you can disable IMDS access for specific tasks. It relies on IP tables rules. You can take a picture of it now if you want, or you can search it online. Now, let's talk about the task role. The first thing you should do is to never grant the task role the poll and discover poll endpoint permission, because if they have this permission, They can impersonate the ECS agent with no need for IMDS. Second of all, don't fall into the trap of the wildcard. If you give task ECS wildcard permission, it contains both of these permissions and also another internal ECS permission, and therefore it's dangerous. So please don't use it. And lastly, keep your task role tight. Give it only the exact permission the task needs and nothing more. Now, what about the task execution role? Don't overprivilege the task execution roles. I saw many teams that believe that the task execution role is only meant for use for ECS, and therefore it's safe to overprivilege. They use one common task execution role to all of the tasks running on the ECS environment. But as we saw using ECS-cape, these task credentials are accessible to each task running on the instance, so be aware of it and give it only the needed permission it needs and only the access to the needed secrets. Please, separate high and privileged low workloads. Don't run low privileged workloads and high privileged workloads on the same instance. You can do it by configuring your capacity manager or by separating clusters. Same goes for tenants in multi-tenant systems. Please give each tenant a different cluster, or at least separate at the EC2 instance level, because you don't want this kind of techniques in action in your cloud environments. So to summarize the best practices, first, separate high and low privilege workloads. Don't let tasks with higher privilege run with one with lower privileges. Second, isolate tenants in multi-tenant systems. And lastly, minimize task and task execution roles, permissions. So, to sum up this talk, I went to AWS and I showed them this vulnerability. AWS responded that it's not present a security concern for AWS. They say that they are going to update documentation and consider long-term defense changes. Remember the documentation that I showed you before, showing the container never has access to other task credentials? Now it's changed to task running on the same EC2 instance may potentially access credentials belonging to other tasks on that instance. Okay. What about the acknowledgement? So I went to AWS again, and they said that they are going to include me in their public documentation changelog and draft a statement of appreciation for me. This is from AWS security blog saying that AWS would like to thank Sweet Security and security researcher Naor Haziz for the research. This is an official statement from AWS. I don't expect you to read it. It's small, but I will read the summary for you. AWS clarified that agent like the ECS agent runs inside the consumer security boundary, so their IAM roles are always in scope for consumer to secure. Containers are not a security boundary. Instance-level credentials remain reachable unless consumers block them. We had a positive engagement, and I'm always glad to work with AWS about cloud security. So to sum up this talk, first, on EC2, task and the ECS agent share the same security boundary. A task can impersonate the ECS agent using the poll and discover poll endpoint permission and hijack the credentials of both task and task execution roles. And lastly, if there's one thing that I want you to take from this talk, please, task level hardening is essential. Disable IMDS access to task running on your instance and keep your task and task execution roles tight, only the needed permissions. So that's it for me. Thank you so much for listening. It was actually my first time talking on Black Hat, and your support is really appreciated. Here are my links. You are welcome to reach out to me and talk with me about cloud security. I would love to talk with each and every one of you. And that's it. Thank you very much. I'm happy to take questions now, if you have any. Yeah? Can you go to the mic, please, so everyone could hear? Yeah.
How IMDS v2 can affect this vulnerability?
IMDS v2. Yeah. So IMDS v2 essentially means that you should get a token from the instance that you are running on. And because the task itself running on the same instance, it should not affect anything. Essentially, I think for IMDS v2, you can configure some hop factors, so maybe it can affect on containers. But I'm not sure that the ECS agent itself supports IMDS v2. So essentially, that shouldn't be such a change.
Okay, thank you.
Hello.
Hey, man. Thanks for the talk. It's good. Do you find it a little bit ridiculous that AWS wants us to implement our own IP tables rules to mitigate this disaster?
What? I'm sorry?
Do you find it ridiculous that AWS wants us to write our own IP table rules in the Docker file, presumably, to mitigate this?
If I find it ridiculous?
Yeah.
Their official response is that it's the secure consumer responsibility. So I agree with it. And I think that each and everyone here that uses ECS should integrate these best practices because this is the only way to prevent this kind of vulnerability.
Did they mention they might be implementing any other fixes for this?
They mentioned that they might be doing it on the future. They're considering it, but I don't know if they're going to do it yet.
Thanks, man.
Thank you. Any other questions? Okay, guys, thank you very much.